This is geometry lesson 9.9, surface area of prisms and cylinders. So a formula for the surface area of a right prism or cylinder can be found by examining its net. So we're going to talk quickly about nets. That's what we see displayed here on the right. It's the taking of a three-dimensional shape and laying it out flat. All of the faces are flat. So if you cut down the sides of this and then spread out each face flat, we have what's called a net, and we're going to find the area of that net to find the surface area of the shape. So surface area is basically the area of every single face that a three-dimensional shape has. So you could find them all individually, find the area of this side and this side and that side and this side and that side. But we obviously can speed that process up. Instead of doing individual sides, there's formulas that can take care of all of it all together. So real quick, we're just going to examine where these come from, and then we'll actually just jumping into using the formulas themselves. So you have a brown paper lunch bag here, meaning the top is open so that you can put lunch in, and there is a bottom. It has dimensions of 5 by 4 by 10. What is its surface area? So this looks like a rectangular prism, except it doesn't have a second base on top. It just has a base at the bottom because it's open. If we cut this open and lay all of the faces flat, this is one way it could look, depending on how you cut it up. It could, of course, look a little different, but these would still be all of the faces. Maybe this would come off a different side, depending on how you cut it. But these are all your faces. So if you were going to find the area of all of this, you could, of course, just piece by piece do it. So 5 times 4 would be 20. This would be 4 times 10, so 40. 5 times 10 would be 50. 4 times 10 would be 40. 5 times 10 would be 50. So easy enough because they're all rectangles. And then you would simply add all of those up. So you have 90 with 50 and 40, plus another 90 with the other 50 and 40. So that's 180 plus 20. It's going to give you a total of 200 square inches. Now, what we could have done is found what's called the lateral area. We're going to talk about that. The lateral area is all the area of the lateral sides. We've talked about you've got the base on the top and the bottom, and the lateral sides connect those bases. So we could just find the area of those and then add the area of the base after that. And so when we lay those all flat, yes, we could do them individually, but we could also just do it as one big rectangle. So again, this is 9 and another 9. This is an 18 by 10. So 18 times 10 is 180. That would equal the lateral area. We're going to talk a lot about that today. So the lateral area from one base to the other. If you think about it like a soup can, even though it isn't in that shape, it would be the label, right? In the top and the bottom of the can, those are the bases. So the lateral area here is 180, 18 times 10. And then the area of the base, since there's just one, is 20. You add those together for a total of 200. Same process, just a different way of thinking about it. On a very simple shape with rectangles, it kind of just makes sense to do piece by piece because it is very quick. But as we look at more complicated shapes, we're going to want to find the lateral area and then add it to the area of the bases. And the quick way to find the lateral area, we're going to see right here. So where we got this 180, it's the perimeter around the outside of the base is what we're talking about. So here's your lateral areas, these sides here. So the perimeter around times the height. So the perimeter is 5 and 4 and 5 and 4, which we laid out here on our net. So if we take the perimeter, the 18 represents the perimeter around the outside. We times it by the height, which is 10. The height is always the distance between the bases. So this is the perimeter of the base. So even though we're talking about these lateral areas, we worked our way around the base to get the perimeter. That was the 4, 5, 4, 5. And then you're timesing it by the height of the shape. That's the distance between the bases. Sometimes these are going to be sitting sideways, and the height might not go from the top to the bottom. If I lay this on its side, it would still have the same measurements. Okay, it's not always top to bottom. So find the two bases. Those are the matching sides. In a rectangular prism, you could call different sides the bases. Most of the time, though, there's no choice. You have your matching sides. How far apart are they from the bottom to the top? It's 10. So if I had another base on top, if this bag was closed, I would need another 20. I would times it by 2. Since this was a paper bag, though, I've only got the one base on the bottom. All right, so let's try these out now. We're going to start on the front with just the lateral area. So we're not going to find the total surface area here, just the lateral area. So as I look at example number 2, this first one, I've got a pentagon here on top. I've got a pentagon on the bottom. Those are matching, okay, and they are then connected by these lateral faces. So we're going to go ahead and just find the lateral area using this formula. So lateral area equals the perimeter of the base times the height. So I want to plug in real slow here. So perimeter we'll talk about in a second, but let's identify the height. So I've got this base on top, and I've got this base on the bottom that matches it. And they are connected by all these lateral faces. And the height is the distance between this base and this base. Now, in this case, it's standing up straight, so the height is from top to bottom. It makes sense. So that's going to be 9. I'm going to just drop that in there right there for the height. Perimeter now is going to be the perimeter around the base, okay, or the perimeter all the way around these lateral faces. So these lateral faces are all standing up. The distance around them is the perimeter of one of these bases. So the perimeter of this, they're all 9. You can see the markings show you they're all the same. And in this case, it's a pentagon. There's 5 sides. So 9 times 5 is 45. So the perimeter around there is 45. And we're going to do 45 times 9. And we get 405. So the lateral area of this figure is 405. And let's go ahead and put the units in. Area is always in squared units, so squared yards. Now this is not the total surface area. We haven't included the top and the bottom. Another way to think of surface area is the materials it would take to create this as a box. So if this was a cardboard box, you need the top and the bottom. We have not included that. We just found the amount of material needed to create the sides of this. That's the lateral area. On the back, we're going to add in the bases, but sometimes the lateral area can be confusing. Now, of course, you could go one at a time here and figure this out. This face right here is 9 by 9. This face here is also 9 by 9. And in this case, they're all going to be 9 by 9. And there's going to be 5 of those. Okay, so 9 by 9 would be 81. So each one of these is 81, and then if there's 5 of them, I times it by 5, and it's also 405. So that would be a different strategy, but this formula will get you there without having to go one at a time and then add them up. But you could technically go one face at a time and then put them all together. All right, so for the next one, let's create some space here. Again, just finding lateral area on the back will add in the top and the bottom. So the amount of material needed to make the 4 sides here that connect the bases, we're going to call the bases the top up here and the bottom. And these rectangular prisms, there are different options to call whatever you want the bases because you have matching sides on both sides. Remember, those have to be in parallel planes. So over here, I couldn't use these opposite sides. They are not simply connected. Okay, the top and the bottom here, though, are connected. And so for lateral area, we need the perimeter around one of those bases. So it's 10 and 9 and 10 and 9. 10 plus 9 plus 10 plus 9. All right, 10 and 10 is 20. 9 and 9 is 18. Total is 38. So as I start to plug in here, my perimeter is 38, and then the height is the distance between the bases. So connecting these two rectangles, the height is 3. 38 times 3 gives me 114 square kilometers. The reason that the unit's always is squared is because you're multiplying. Technically, this is 38 kilometers around, singular kilometers, not squared. And then this distance is 3 kilometers. And when you multiply kilometers times kilometers, like an x times an x, it's x squared or kilometers squared. So whenever we're multiplying units together, we end up with squared, and that's where area is always going to have square units. All right, sliding down, let's get this in focus for you. So now we have a cylinder. It's going to follow the same structure here. So here's a spot where it's like, okay, I got to get the lateral area, which is where the label would be if this was a soup can. All right, so if I rolled this all the way up flat to a net, that label would be a rectangle and the height would be 5. And then the length across the top, the width, would be this total distance around the circle, where if I cut it and I took the label off and laid it flat, the distance that it curves around this full can would lay flat and be the top of the rectangle. Okay, so we'll come back to that. Let's lay that out. So if I had the label here, from top to bottom, it's going to be 5. And we're going to have to figure out what's the distance here. And if I multiply those together, that would be the area of the label, which is the lateral area in this case. All right, so let's think about what we need here. We need the perimeter around the top. We'll talk about that here in a second. And then the height is the distance from one base to the other. So my bases, remember, are your matching sides that are parallel to each other and exactly the same size. They are connected. One could be considered the translation of another. I have this base, it's translated up 5 kilometers. I now have it up here, and they are connected by these lateral faces, which in this case is one big curved face. Okay, so the height is the connection between those bases. That's just going to be 5. So just like here in this rectangle, if I was finding the area of the label, it would be length times width, 5 times something. Same thing here. That's what this actually represents. So let's find the perimeter of the base. So the base is a circle. Perimeter of a circle is circumference, which we've studied as pi times diameter. Cherry pie is delicious. Okay, the diameter of that circle is 8. So the circumference, you drop diameter of 8 in, so it's 8 pi. That's the perimeter of the circle. That's what's going to drop in right here. And I would multiply those across. And we're going to leave pi in our answers here. So that is 40 pi. If the direction said round to the nearest tenth, you just put pi in your calculator, or 3.14. So this distance around the circle, if I laid that label flat, that distance right there is 8 pi. So the rectangle that forms the label has a length of 5 and a width of 8 pi coming from the circumference. Okay, so this right here would be the area of the label. So we're not including the top and the bottom. This is not the amount of material needed to create the can in terms of the metal or the aluminum. This lateral area would be just the amount of material needed to create the label. And then obviously in the real world, we would get this down to a decimal form, something more usable. We wouldn't use 40 pi, but for here in class, we're going to go ahead and leave it just as that. Okay, and then this is probably one of the more complicated looking ones. Everybody wants to call the base the top and the bottom here, but the matching sides of this are trapezoids. So I have this trapezoid here, and then I've got this other trapezoid that runs parallel to it on the back side. If you can see those two, those are the bases. The bases must match in size and be parallel. So the top and the bottom, the way this is sitting, they run parallel to each other, but this bottom is smaller than the top. So when we're calling this a prism, those cannot be the bases. The bases must match and run parallel to each other. So the matching sides are the trapezoids. So as we run this through lateral area, it's the area of all of these faces. So not the trapezoids, but the area of all the other faces. Now they're all rectangles. So you could do 8 times 7 to get the top. You could do 8 times 4 to get this side. This would be 4 times, you have to be careful, 8 here. And this is 8 times 4 over here. And then you could add them all up. And we would get the same answer as we're going to get here. But we're going to go ahead and shortcut it and use our formula. So we're going to put in the perimeter of one of the bases. times the height. The height is the distance from one base to another. So all of these connecting lines from one trapezoid to the other trapezoid, those are all 8. Now in this picture, there's so many numbers, it can be confusing which one we need to grab. But 8 is the height, it's the distance from one base to the other. Perimeter, remember, is around the base. So take one of these trapezoids and add up all of the sides. So right here in the red one, we've got 4 across the bottom. As I move up, that distance there is 4. As I move across the top, be careful it's not 8, don't grab that number. That distance across the top of the trapezoid is 7, and then back down is 4. So it's 4, 4, 7, and 4. That comes out to 4, 4, and 4 is 12, plus 7 is 19. So the perimeter here is 19. 19 times 8 is 152. Okay, so again, we could have gone 8 times 7. That's 56. Over here, we could have done 8 times 4. That's 32. This other side would also be 8 times 4. So 32. And then on the bottom, this is again 8 times 4 because this is 8 right here and this is 4. So another 32. So if we add those up, 32, 32, 32, 56, the lateral area is 152. So that would be a different strategy and that would be okay. But again, as we have more complicated shapes, we're going to want to go ahead and just use the simpler formula of the perimeter times the height. Now again, this was just to find the lateral area as if you were finding the label on one of these cans. The total surface area has to include those sides, those bases. So we're going to add that in here on the other side. And that now will give you the total amount of material needed to create the entire shape. Now you'll notice here as I flip to the back, we're going to take the lateral area, which is what we found on the front, and we're going to add the area of the two bases. So then we will have the total material that it takes, like if this was a cardboard box, how much material is needed to create the entire box, how much is on the outside, if you were wrapping it in wrapping paper, how much material does it take. And this is the kind of thing that if you're in any kind of industry that's creating this stuff, whether it's a box or whether this is just some other kind of solid that you need for a tool or for anything like that, you need to calculate the surface area, how much material is needed to create it if it's hollow. If it's volume, if you're filling this in on the inside, that's different, and we'll get to that. So the shapes that I've given you here on the back, we've already done the lateral area part, and we're just going to add the area of the two bases. So when we want to find total surface area, we start with the lateral area. So surface area equals the lateral area plus the area of the two bases. So since we've already calculated the lateral area, we can just drop that in. So if I flip back to my other side, my lateral area for this shape was 405. I've already done that work. So if I was starting from scratch here, I would need to go ahead and recalculate the lateral area. And then I'm going to add the area of the two bases. So let's find the area of a base right here. This specific base is a regular pentagon. So we're going to have to do 1/2 little a, little p. We have all the information we need. Little a was given to us right here. It's 6.2. And then the perimeter around the outside of that shape, 9 times 5 is 45. You multiply that all together, and you're going to get 139.5. And I make this careless mistake all the time when I'm doing these. If you're going too fast, you're going to grab this, you're going to put it right here as the area of the base, add it, and then you're going to get the wrong answer because this is just the area of one base, right? If we're coming up with the total material to make all of the sides, the lateral area is all of these faces, and I need two bases because this is not open on top like the paper bag was. Base on the top, base on the bottom. So I have to now times this by 2. So you could list that right here, 2 times 139.5, and plug that all in your calculator. Lateral area plus the area of two bases, and that gives you the total surface area of 684. Okay, right here. surface area equals lateral area plus area of two bases. We'll steal the lateral area off the other side. We already calculated it. It's 114. Two bases. So we called the bases the top and the bottom. So that's nice and easy. Area is just base times height because they're rectangles. So area equals 10 times 9, or 9 times 10, whatever. Okay, so that's 90. You would double it, be 180. I'm going to write it as 2 times 90, but you could drop it right in as 180. And you're going to run all those numbers, and that comes out to 294. So again, we did most of the hard work already, the lateral area. Now we're just adding on the top and the bottom. Area of one of the base times 2 because there's 2 of them, and we just add them together. All right, going to the cylinder. So surface area equals the lateral area plus the area of two bases. Let's go ahead and grab the lateral area. We did it on the other side. It was 40 pi. That is the area where the label goes. Now we're finding how much material it would take in terms of the metal can. So we do need the top and the bottom. So we're finding the area of a base. Well, that base is a circle. Area of a circle is pi r squared. Be careful, don't grab the 8. That's the diameter. Radius would be halfway across, so 4 squared. So area equals 16 pi. There's two bases, so 2 times 16 pi. Well, that would be 32 pi. And we're going to add that to the 40, and my total surface area is 72 pi. Okay, on the next one. Lateral area we already calculated, and then the two bases. The bases are trapezoids, so when we go to find those, we got to use the trapezoid formula. So let's go ahead and drop in the lateral area from the other side. It was 152. And now we got to find the area of one of those bases and then double it so we have both. All right. So now just looking at the trapezoid, I can tell you this height right here will confuse people because we did the height of the three-dimensional shape being 8, the distance between the bases. That's not the height we're talking about here, so we can't put 8 there. We're now just talking about this two-dimensional base, this trapezoid right here. So you can kind of cover up everything else and just worry about this. The height of the trapezoid is the distance from base 1 to base 2. They've given it to you. It is 3.7. All right, and then the bases added together. Up top we have 7 and 4. 7 across the top, 4 across the bottom. Bases of a trapezoid must be parallel. All right, you run that all the way through, and that becomes 20.35. That's the area of one of these trapezoids. We do need to double it, so we put the 2 right here. 20.35, and that comes out to 192.7. Okay, the last two now, brand new shapes. We're gonna have to find the lateral area and the area of the bases. Okay, we don't have that. I'm gonna ask that you, if you're working along with the video, obviously if you're watching this, you are, pause the video, try these two on your own, see where you make mistakes, see where you get stuck, then press play again, and then go ahead and see what you may or may not have messed up. Okay, so for the surface area, we need to find the lateral area, add it to the two bases. So lateral area, remember, is going to be the perimeter of one of the bases times the height of the three-dimensional shape plus 2 times the area of a base. So you can conquer this in any order that you want. These are the bases right here. These two matching triangles. Remember, the bases are always going to match. All right, let's start with the perimeter times the height here. So perimeter here is the distance around the base, which is 6. This side here is 8. And then the bottom is 10. So if I put that all together, that's 24. That's the P. That's perimeter here. So 24 times the height, the distance from one base to the other, that's 10. And then I need the area of the base, and I'm going to double it. So it's going to be 2 times whatever the area of one of these bases are. These bases are triangles, so it's 1/2 base times height. So we got to keep all our formulas straight. Remember that the base and the height always hit at 90, so look for your 90. My 90 is right here in a right triangle. The 90 degrees tells you the two sides are your base and your height. This one is 6, and this one is 8. So it's 1/2 times 6 times 8. That's going to come out to 24. Remember that that's the area of just one base. We do need to double it so we can get our total area there. And so this is going to be 240 plus 48. So my total surface area is 288. All right, and now my last one, tricky one here. Because it's not a full cylinder, it's a half cylinder, we're going to have to kind of be careful and go about this in a very deliberate way. So our surface area is going to be, so our lateral area first, plus the area of my two bases. My lateral area is going to be the perimeter of one of these bases, which is going to be a little tricky because it's a semicircle. Okay, you can't just take the perimeter of the circle and take half. That's not going to work because half the perimeter of the circle would just be the outside. We're going to have to add in that 6. Okay, so we'll take care of that. Times the height, which will be 8, plus the area of the two bases, which are circles, but we'll have to take half of those. Okay, so let's start with perimeter of one of the bases. We are going to have to calculate this with circumference. We need half though, half of a circle, not the full circle. So circumference is pi times diameter, and we're going to take half of it. Now that will only give me this semicircle. I'll have to add in the 6 to go across this. We're finding the perimeter of the base. Okay, the diameter is 6, so that would drop in for D. So it's 6 pi over 2, which divides to 3 pi. So the circumference of this outside part right here is 3 pi. And I have to add in this straight side here of 6. So my perimeter is 3 pi plus 6. 3 pi for the curve, 6 for the straight line. Okay, and that's finding my total lateral area. I also need to times that here by the height. So this thing in parentheses is just my perimeter around the top. 3 pi on the curve, 6 across, times by the height of 8. That's going to give me the lateral area if I was going to cover these sides with a label on the flat side and the curved side. Okay, that will give me my lateral area. And now I need to find the area of the bases. So they are semicircles. It's going to be pi r squared for a full circle. So we'll divide it by 2 to get a semicircle. And then we'll end up going back and doubling it because there's 2 of them. So you could think about it differently as just finding one whole circle, because if you put these two halves together, it's a whole. But I don't want to make it too complicated here. So the radius, remember, is not 6. The radius goes halfway across. So the radius is 3. So it's going to be pi times 3 squared divided by 2 because it's a half of a circle. So I get 9 pi over 2. That's the area of one of the bases. We will double that. So let's do some math here. We're going to distribute. That's going to be 24 pi plus 48 plus, that's the whole lateral area right here, plus, now when I multiply here 2 over 1, these 2's end up canceling because I'd be dividing by 2 and then timesing by 2. So this just comes out to 9 pi. The 2's cancel. And now I can combine everything. If we have a pi, treat it like an x. I can only combine like terms. So the 24 and the 9 are going to go together. That's going to be 33 pi. And then the plus 48 will tag along. So this would be like a challenge question. But if we can handle this, we can handle anything that could be thrown at us.